Right, let's start chapter 5 today. Chapter 5 is a cool chapter. You're going to like it because we're actually going to start doing some chemistry. Okay, this chapter is called chemical bonding. So up to now in chemistry, we have talked about atoms individually, by themselves. So hydrogen all by itself right here, or oxygen all by itself. But in this chapter, we're going to find out and learn how they come together and form compounds or molecules. How hydrogen will hook up with oxygen, and another hydrogen hooks up with oxygen, and what does it make, guys?
Water.
Yeah, it makes H2O.
Water.
Okay, so we're going to talk about how they bond together, chemical bonding, and it will help you understand how elements on the periodic table will find other elements on the periodic table to make a compound with.
Wait, does that have anything to do with valence electrons?
It has everything to do with valence electrons.
What about
Very good.
covalent bonds?
Okay, let's get started.
Covalent bonds though?
Yeah, covalent bonds is one of them. Ionic is another one. So there's three. We're going to talk about all of them, okay? We're going to talk about all of them. You need to write this down, though, in your guided notes. Please be following along. Chapter 5 guided notes. Chemical bonds formed by the attraction between the positive nucleus of one atom and the negative electrons of another atom. So if you have opposite charges, what do? They attract each other. So the positive nucleus of one atom will attract the electrons of another atom, and that's what pulls them together and forms a chemical bond. Okay? So that's what we're seeing down here with water. Chemical bonds form between atoms by combining valence electrons only. It's only that outer shell of the electrons in the highest energy level. All these inside electrons, they don't determine bonding. So we just look at the valence electrons. How many valence electrons does hydrogen have, guys? Has one, so it's right here. You see a dot. Here's another hydrogen, so it's got one. How many does oxygen have? 6. So if you count here, 1, 2, 3, 4, 5, and 6. How many do they want? 8. To obey the, what rule did we call that? The octet rule. So they want 8. So if, guys, look here. If this hydrogen comes up and shares the electrons right here, would oxygen feel like it has 8? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. It would obey the octet rule. So oxygen really doesn't mind that hydrogen comes in and shares the electrons. What molecule did we just make? Water. Water. And what's cool about chemical bonding is now you form something new. Hydrogen is a gas at room temperature. Oxygen is a gas at room temperature. But when they all form together and form a chemical bond here and form water, is this a gas at room temperature?
No.
It's a liquid, so they have different physical properties. They have different chemical properties. You're making something new entirely, and so that's what's cool about chemistry. Everything changes when you make a new compound or a new molecule. Okay, valence electrons. You have to write the definition in your guided notes. They are electrons in the highest energy level, the outermost shell. They are the electrons available for bonding. So valence electrons are in the highest energy level, and these are the electrons available for bonding with other atoms, with other elements. So I've got a picture up here of aluminum. How many total electrons does aluminum have? 13. If you counted all these black dots here, there would be 13. Now, how many of those 13 are valence electrons? 3. Okay, this is a valence electron, this is a valence electron, and this is a valence electron. What do we call all the other electrons? So all these black dots now, what do we call them? They're not valence. I always refer to them as the inner electrons because they fit closer toward the nucleus. The valence electrons are the outermost shell, the ones in the highest energy level. So aluminum has 3 valence electrons.
So they're like inner valence?
So they're just called inner electrons. They're not valence. The ones on the inside. Okay, so which electrons are available for bonding? Well, it's only these 3. If aluminum wants to bond with somebody else, it's going to form a bond with those 3 electrons.
So what about the middle ones?
They don't do anything.
They can't bond at all?
You're talking about these middle ones?
No. Like the ones in the middle that we say.
Oh, no. The metals, the transition metals, we'll get there. We'll get there. Okay, so here's a diagram, an electron dot structure for Einsteinium. Guys, how many electrons does Einsteinium have? Its atomic number is 99, so it's got 99 dots here. But how many of them are available for bonding? 2, because it only has 2 valence electrons. So all these other 97 electrons in here don't matter. Okay? It's just the valence electrons. Okay, let's review. I know that we've talked about this before. Guys, how many valence electrons does group 1 have? 1 valence electron. All of those guys have 1. How many does group 2? 2. You're supposed to be writing this down in your notes. Hopefully you are. Group 2 has 2.
3.
Group 13 has 3. Group 14 has 4. Group 15 has 5. Group 16 has 6. 17 has 7. Now 18 has 8, except for which one?
Helium.
Except for helium, which has 2. Okay. So that's an easy way of determining valence electrons. Okay, now let's talk a little bit about the transition metals. I told you before that we were going to wait on these guys here. Whoops. Okay. The transition metals can either have 1 or 2 valence electrons. It's a little bit complicated with the metals. So we'll talk about that coming up, but it's either 1 or 2. The inner transition metals also either have 1 or 2 valence electrons. It can change. Okay, in electron dot structures, we talked about them before. The chemical symbol represents the atom's nucleus and inner electrons. So the symbol right here for H, this symbol H represents the nucleus of the hydrogen atom and all the inside electrons. Although hydrogen doesn't have any inside electrons. While the dots represent what, guys? The valence electrons. So this oxygen here, the symbol represents the nucleus and the inside electrons. The dots represent valence electrons. Okay, so if it has 1 valence electron, it has 1 dot. If it has 2 valence electrons, how come they're so far apart? Do electrons like to be by each other? No. So they will move as far apart from each other as possible. 3 and 4 valence electrons. 5, 6, 7, and 8. So when you do a dot structure, the most electrons you can have on one side is what? 2. Everyone's looking to get 8. Okay. 2 on each side. Okay, how many dots would lithium have, guys? Just 1. It has 1 valence. What about beryllium? Since it's in group 2, it's got 2 dots. Boron 3, a carbon 4. Nitrogen has 5, oxygen 6, fluorine 7, and neon, a noble gas, has 8. Okay. All right, so let's get into bonding, how they form bonds with other elements. First of all, a chemical bond is a force that holds a group of atoms together. A chemical bond is a force that holds a group of atoms together. And it makes them function as a single unit. So when I say chemical bond, it's just a force that holds a group of atoms together. Helps them to function as a single unit. Well, there's two main types of chemical bonds. The first one that we're going to learn about is called an ionic bond. In ionic bonds, there's a complete transfer of electrons from one atom to another. So one atom just gives its electrons to the other atom. Covalent bonds. This is what Brandon was talking about earlier, right?
Right.
Covalent bonds, they share the electrons. They share those valence electrons between the two atoms. So they kind of share it. It's not a complete transfer like ionic bonds. They share them. So two main types of chemical bonds are ionic, transfer of electrons. Covalent, they share the electrons. Okay, to kind of preview the chemical bonds that we're going to talk about, I've got a table in your guided notes that looks exactly like this. So take a second to fill this out. If you're watching the video, please hit pause and fill it out. When you're done, then hit play. Alright. Okay, this table is going to be very important. By the end of this chapter, you should know everything on it. Okay? What are the electrons doing? Well, in an ionic bond, they're transferred. In a covalent bond, they're shared. Metallic bond, they're also shared. But you need to know what type of elements are involved in an ionic bond. Well, it's a metal and a nonmetal. So something below the staircase, something above the staircase. What about covalent bonds? Two nonmetal atoms, so they're both above the staircase. In metallic bonds, that one's pretty obvious, right? Two metals, so it's something, two atoms below the staircase. Anyway, by the end of this chapter, that should be something that you know just off of memory. Okay, let's start learning about a new concept. We haven't talked about this before, but atoms can gain or lose electrons. You can take electrons away, and you can give atoms electrons. So an ion is an atom that has gained or lost electrons. You need to write that in your notes, I'm pretty sure. An ion is an atom that has gained or lost electrons. So if it's missing electrons or it's got extra ones, we call it an ion. Well, there's two types of ions, okay? The first type is called a cation. That's right. You're right. A cation is an atom that has lost electrons. And what charge would you have, guys, if you lose an electron?
Positive.
Okay, let's get this straight. So what charge does an electron have? It has a negative charge. Well, if you're an atom and you lose an electron, what charge are you going to have?
Positive.
You're going to have now a positive charge. Why do you have a positive charge?
Because you lost one of those.
Because did you lose any protons?
No.
No, but if you lose an electron, now you have more protons than electrons, so you have a positive charge. Does that make sense? How do we remember that?
Because the cat got ran over.
Yeah, remember the cat? Guys, draw your cat there in the margins.
So you're happy you lost the cat?
No, because the cat died.
Okay, remember the cat got ran over and his eyes turned to plus signs? Where it's positive to kill cats. I don't know. Unless you're a cat person.
One thing that I remember is like the eyes are like
Yeah, that's what it's supposed to. Hey, okay, my turn. I'll wait. Hey, listen up, guys. When the cat got ran over, his eyes turned to crosses, so it's a plus. So that's how you're supposed to remember it. Cat ions, get it? Eyes are positive.
Is it okay if I just drew like a cat getting ran over?
But put his eyes as plus signs.
Okay.
Okay.
I just didn't write any words.
Yeah. No, that's fine. Here's another way that I remembered it going through school. If you look at cation, there's a T. A T makes a plus sign.
Can we just turn that into a plus sign?
A T makes a plus sign, so they're positive.
So I
Okay.
can write that.
Yes. Okay, the second type of ion is called an anion. Second type is called an anion. Write it down. An anion is an atom that has gained electrons. So when you gain electrons, now you gain more of those negatively charged particles. What charge are you going to have? It's going to be a negative charge. Because you've got more electrons, which are negative. That should make sense, right? So cations are positive because they lost electrons. Anions are negative because they have gained electrons. All right. Here's some examples. Let's talk about some examples real fast. Sodium, is this a cation or an anion? It's a cation. Fluorine with a negative charge. Is it a cation or an anion? Anion. What about magnesium here? Cation. What about oxygen? Anion. What about aluminum? It's a cation. Okay, so those are some examples. Now we're going to talk about how to know if it's going to be a cation or an anion. This is very important. I want you to get your periodic table out. If you're watching the video, please, it doesn't matter which one, maybe all of them. Because we're going to label something that's very important. Okay? The first thing that I would like you to put down, if you haven't already, is the valence electrons. These guys have 1 VE. These guys have 2 VE. You skip the transition metals. These guys have 3, 4, 5, 6, 7, and 8. Except for helium, which has 2 VE. Okay? Now, how many does everyone want? I keep asking this, but how many do they want? They all want 8 valence electrons to obey the what rule? Okay. Now watch this. Very important. Look up here. For group 1 elements, they have 1 valence electron. Would it be easier for them to get 7 more or to lose this 1 to become like a noble gas? It's easier for them to lose 1. What charge would they have if they lost 1 valence electron? Positive 1. So above this group, I want you to put plus 1. That's because everyone in group 1 is going to form a plus 1 charge. Why? Because they want to get rid of this 1 valence electron. It's easier for them to do that to become like a noble gas. So let me ask you this. If sodium lost 1 valence electron, what noble gas would it become like in terms of its electron configuration? It would become just like neon. And that's what it wants. Right? Okay, stay with me. Group 2 has 2 valence electrons. Easier to gain 6 more or just lose these 2? Lose 2. So what charge would they have if they lost 2? They would now have 2 more protons or plus 2 charge. Okay, so everyone in group 2 is going to have a plus 2 charge. Comprende?
What would hydrogen go to if it loses 1? There's no noble gas before it.
Oh, good question. If hydrogen loses 1, what is it? There's not a noble gas before it. But yeah, it just doesn't have an electron at all.
So it's just dead?
It's just no electrons. Yeah. It's just, actually what they call that is a proton. Because all it is 1 proton.
So it's just,
Just a proton. Okay, very good question though, Case. All right, let's go to group 13 here. Guys, easier to lose 3 or gain 5 more? Lose 3. So if they lose 3, what charge will they have? Huh?
Plus 3.
Plus 3. So above the group 13, I want you to write plus 3. All of these guys will form a plus 3 charge. All right. Now, group 14 is a little interesting. Easier to lose their 4 valence electrons or easier to gain 4 more?
Either one.
Either one. So let's put plus or minus 4. Plus or minus 4. Okay, let's go to group 15. Easier to lose 5 or gain 3 more? Gain 3. Well, now, when you gain 3, what charge are you going to have? Minus 3, because now you have 3 more electrons. So everyone in this group, group 15, forms a minus 3 charge. Group 16, easier to lose the 6 it has or gain just 2 more? Gain 2 more. So it's going to be a minus 2 charge. So everyone in oxygen's group here, minus 2. What about the halogens? Easier to lose these 7 or just gain 1 more? Gain 1 more. So they're going to form a minus 1 charge. What about the noble gases? They are not going to lose nor gain electrons. So just put a 0. They're neutral. Okay. So on every one of your periodic tables, I want you to label plus 1 for group 1, plus 2 for group 2, plus 3, group 13, group 14 is plus or minus 4, group 15 is minus 3, minus 2, minus 1, and 0. And hopefully we understand why. Do we? Okay. Before I move on, groups 1 and 2, are they anions or cations then? Cations. What about group 13? Cations. So basically, everything below the staircase is what? Cations. Metals will tend to lose electrons, which make them into a cation. Now, nonmetals, what do you see when you get to the nonmetals? They're cations or anions? Anions. So nonmetals will tend to gain electrons. That's the trend. All right, practice problem number 1 in your guided notes. It says, for each of the following, decide whether the atom will gain or lose electrons, and determine the charge of the ion, and determine if it will be called a cation or an anion. So let's go to number 1. Lithium. Guys, is it going to gain or lose electrons?
Lose.
Yeah, it's got 1 valence electron, so it's easier for it to lose than to gain 7 more. It's going to lose that 1. What's its charge going to be? Plus 1. Just look at where it is on the periodic table. It's in group 1. Those guys are all going to be plus 1. Cation or anion? Positive, so it's a cation. Okay, oxygen. Find it on your periodic table. How many valence does it have? 6. Easier to gain 2 more or lose those 6? Gain 2 more. So it's going to gain. What's its charge going to be if it gains 2 more? Minus 2. Cation or anion? Anion. Okay, now I'm going to scroll through here. I think it goes to 7. No, 8. I would like you guys to try the rest of them on your own. If you're watching the video, please hit pause. Try them first. Then hit play once you've got them all answered. We'll see if you got them right. All right, let's see if we got them right. Magnesium. It's in group 2. Easier to lose those 2 or gain 6 more? Lose 2. So it's going to lose, and it's going to have a charge of plus 2. Cation or anion? Cation. It's positive. Remember, cats are positive, right? We like cats. All right, bromine. If you find it on the periodic table, it's in group 17. It's a halogen. It has 7. Guys, stay with me. Will go. Easier to lose 7 or gain just 1 more? Gain 1 more. So did you circle gain right there? You did? And what's its charge going to be?
Negative.
Minus 1? If it gains 1? Is that a cation or anion?
That's an anion.
It's an anion. Very good. Okay, potassium. I feel like we should ask Kaiser back there. Potassium. What'd you put here? Gain or lose? Potassium has 1 valence, so it's easier for it to lose that 1 than to gain 7 more, right? Okay. When it loses 1, what charge does it have? +1. And it's called a what? A cation. Okay. You could use your periodic table to just find it, find what column it is, and know the charge. And whatever. Okay, now here's a tricky one. Here's a tricky one, Tristan. So, neon. Is it going to gain or lose?
It is going to not do anything.
Yeah, neither. So don't circle gain or lose. It's a noble gas. It's not gonna have a charge, so I'll put 0 there. Is it a cation or an anion? No, it's just a neutral atom. It's neither. Okay, nitrogen. How many valence? 5. Easier to gain 3 more or lose those 5? Gain 3 more, and when it does, what charge will it have? -3. And is it an anion or cation? Anion. Okay, last one. Cesium is an alkali metal group 1. 1 valence. Easier to lose 1 or gain 7 more? Lose 1. So it's going to lose. When it loses an electron, you have a +1 charge, and it's a cation. Very good. Okay. So, before I quit the video, let's review what we just talked about. Atoms can either gain or lose electrons, right? When they lose electrons, now it's a positive charge, and we call it an anion or cation? Cation. When it gains electrons, though, now what do we call it? An anion. And is that positive or negative? Negative. Hopefully you have labeled your periodic table. Okay? Hopefully your periodic table looks like this. Did we label it? Okay, then all you have to do, for example, is find it. If it's sulfur, -2, anion or cation? Anion. Okay. Hopefully we have learned something. Please, guys, now that we know that,
Is that thing that says create review?
there is a worksheet in your student workbook called Ions Worksheet. Please go there, Ions Worksheet, and let's get that done. And hopefully this video helps.